Okay, so this is question number 27 of the Magnetic Fields homework booklet. So question 27 starts off with this question, where we have some domestic users, so that's users that live in a house in the UK, and they're supplied with a mains electricity at a root mean square voltage of 230 volts. So first of all, we're asked to simply state what is meant by a root mean square voltage. So this is just something you have to learn. So the definition of root mean square voltage is the equivalent direct current voltage or equivalent DC voltage that produces the same heating effect, and it's the heating effect bit that's important. If you simply state that, then that gets you 1 mark. For part B, at least the first part of part B, we're then asked to calculate the peak value of the supply voltage. So in the question, if we go back up here, we're told that the root mean squared voltage is 230 volts, and we want to know what the peak value is. So if we look at this equation, the root mean squared voltage is equal to the peak voltage divided by root 2. So if we just rearrange that, the peak voltage is root 2 times the root mean square voltage. The root mean square voltage was 230 volts. So if we multiply that by root 2, it gives us 325 volts. So there's 1 mark for using the right equation and putting the right numbers in. There's 1 mark for the right answer. And then in part 2, we're then asked to calculate the average power that's dissipated or used up in a lamp that's connected to the main supply when the root mean square current is 0.26 amps. Well, the average power is equal to the root mean squared current multiplied by the root mean squared potential difference, or root mean squared voltage. We know the root mean squared voltage was 230 volts because it told us that in the question at the start. The root mean squared current, it just tells us that in the question up here. So if we multiply these two numbers together, it will give us the average power. And if we do that, we get 60 watts. So that's just worth 1 mark for putting the numbers in and getting the right answer. And then finally, we're then told that the frequency of this electricity or voltage supply is 50 hertz. And we're asked to draw on these axes, which are here, the waveform of the supplied voltage. And we're told that we have to label the axes with appropriate values. So the first thing, if we think about the actual voltage axis, well, we know that the peak voltage was 325 volts, because that's what, if we go back up here, all the way up here, then this is what we worked out here. So the peak value is 325 volts. So for our y-axis, we've got to go up to at least that. Because there are 4 divisions, if you like, then it's really easy to just put these up and go up in 100 volt steps. So that's the first part. The y-axis is a little bit more tricky because it just gives us, in the question, it just tells us the time in milliseconds. It doesn't give us any of these numbers. So we have to go back to the question. So we're told that the frequency of the voltage supply is 50 hertz. So if we then use this equation that links frequency and the time period, then the time period is actually 0.02 seconds, or in other words, 20 milliseconds. So on the x-axis, we need to go up to at least 20 milliseconds. So I've gone up in steps of 5 milliseconds. I've gone up to 25 milliseconds, but I could have gone on a little bit further. And it's a sinusoidal curve. So basically, it's just a sine curve that has a time period of 20 milliseconds. It's got a peak value of 325 volts, and there are 4 marks to draw in this graph. So you get 1 mark for the shape. You get 1 mark for this sinusoidal shape here. The second mark is for correctly labeling the y-axis, or with a reasonable scale. The third mark is for having the correct peak values. So then you'd have to go back and check and say, right, have I actually marked these things off at around about 325 volts within a millimetre? And if you have, that gets you your third volt. And then finally, the correct time period. So this thing here, it does 1 cycle in 20 milliseconds, which is consistent with the frequency that's given in the question. So you do all 4 of those things, and that gets you 4 marks. So that was question number 27 of the Magnetic Fields homework booklet.